This one is definitely not easy. You're going to have to know some pre-calculus or calculus in order to have a shot at this. But you always have a shot at it because you have a 20% chance of getting it right just by guessing. Make sure you do not leave any blank. At least guess. 20% chance is better than 0. Put an answer down. Hope for the best. Triangles ABC and PQR are shown below. The given side lengths are in centimeters. The area of triangle ABC is 30 square centimeters. What is the area of triangle PQR in square centimeters? From the world of pre-calculus or calculus, which is what's called an area of an oblique triangle, where you have two sides that are given to you and the included angle. The area of that would be 1/2 BC times the sine of A. So in this case, it'd be 1/2 XY times the sine of 70, or in this case, 1/2 XY times the sine of 110. Well, we have up here the triangle ABC is 30, so we can put that in for the area. Using this, we can say 30 is equal to 1/2 times the sine of 70 times XY. Now let's see what happens. I'm going to actually give you some insight what I'm doing. I'm going to solve this for XY, and you'll understand why when I'm done. So to solve this for XY, first of all, we have to find the sine of 70, or at some point you have to find the sine of 70. It's 0.93969. And then you can do this different ways, but I want to solve this for XY. So you can multiply both sides by 2. You get 60 equals 0.93969. Then divide each side by that, or really you're dividing each side by the sine of 70. It's going to be 63.85. So x times y is 63.85. Let's do the same thing for this triangle. The only difference with this triangle is we don't know the area. We can still work through this formula. 1/2 times the sine of 110 times xy. Well, the sine of 110 is 0.93969. Now you might notice something here, especially if you look back at this one, because these two lines are the same. Remember what's being asked here is you're asked to find the area of triangle PQR. That's what you're finding. Well, if this is the same as this, then the areas are going to be the same. So the areas are equal. And that means if this area was 30, this area is also 30, which is letter J. That's a tough one. Well, here's another easy one. Triangle ABC is shown in the figure below. The measure of angle A is 40 degrees, AB is 18, AC is 12. Which of the following is the length in centimeters of side BC? So they give you all that information in the drawing. They do give you a couple notes, and when they give you these, you're most likely at some point going to use them. For a triangle with sides of length A, B, and C, opposite angles, angle A, angle B, and angle C respectively, the law of sine states the sine of angle A over side A equals the sine of angle B over side B equals the sine of angle C over C. That is the law of sines. The law of cosine states that if you're dealing with an angle C, then side C squared equals A squared plus B squared minus 2AB times the cosine of that angle C. Well, we're given angle A here. So we're going to alter that law of cosines. We're going to say A squared is equal to B squared plus C squared minus 2BC times the cosine of the angle we're given, which is angle A. So this is the law of cosines. We're going to alter that to fit what we're dealt here, the hand we're dealt. We're given a 40-degree angle at A and these two sides. Side C is 18, side B is 12, so we can use the law of cosines, but we have to alter it somewhat to match what we're dealing with here with this angle A. So now the law of cosines, A squared equals B squared plus C squared minus 2BC times the cosine of angle A. Angle A is 40 degrees, side B is 12, side C is 18, substitute in. So A squared equals B is 12, that's 12 squared, C is 18, it's 18 squared, minus 2BC would be minus 2 times 12 times 18, and times the cosine of angle A is 40 degrees. We need to find the length in centimeters of side BC. Well, side BC here is across from angle A, so I have that labeled as side A right there. So we need to solve this for A. So ask yourself, how do you take that equation right there and solve it for A? Because it's one step. Since that is A squared, you only have one step left, believe it or not. Take the square root of each side. If you take the square root of each side, obviously you can see it's the square root of 12 squared plus 18 squared minus 2 times 12 times 18 times the cosine of 40. All we did there was use this law of cosines and alter this to fit what we're dealing with here, which is angle A. side B and side C, and solve that for A, we end up with answer E. Not an easy one, but it is possible. What is the sum of the first four terms of the arithmetic sequence in which the 6th term is 8 and the 10th term is 13? So once again, the 6th term is 8, the 10th term is 13. We need to find the sum of the first four terms. An arithmetic sequence is a sequence in which there's a common difference. That means you're adding something that's the same each time you jump from number to number. So there is a common difference that you're adding each time you jump from number to number. So what you're looking at here, the 6th term is 8, the 10th term is 13. There's a span there of 5. From 8 to 13, that's 5. And you're making what I call jumps. When you jump from number to number, you're making 4 jumps. So that span of 5 is made up of 4 jumps. So each comma represents a jump. So if you take that span of 5 and you divide it by those 4 jumps, that will give you that common difference that we're looking for. Once we get that common difference, then we can work backwards from 8 to get those first 4 terms. So divide 5 by 4. That span of 5 divided by 4 creates a common difference, or in other words, 1.25 each jump. So each time you jump from number to number, you're adding 1.25. If you take 1.25, 8 plus 1.25 is 9.25, plus another 1.25 is 10.5, plus another 1.25 puts you at 11.75, and then another 1.25 puts you at 13. So that checks out that the span, or the common difference, is 1.25. So let's go backwards now from 8, because we need the sum of the first 4 terms. This is the 6th term. So go backwards from that to get the first 4 terms. So if you work backwards from 8, now subtracting 1.25, the 5th term is 6.75, the 4th term is 5.5, 3rd term 4.25, 2nd is 3, and the first term is 1.75. We need to find the sum of those first 4 terms. So the sum of the first 4 terms, just to add those up, is going to be 14.5. So the sum of the first 4 terms is letter G, 14.5. This is one people often struggle with, but there's really no reason for it, especially if you've been through Algebra 2. In the equation x squared plus mx plus n is equal to 0, m and n are integers, the only possible value for x is negative 3. What is the possible value of m? So you're told right there the solution to this quadratic equation. Now, people come out of Algebra 2, they know how to solve quadratic equations, but sometimes they don't know how to work backwards from the solution to get the equation. And that's what you're given here. If it's a quadratic equation where the exponent is 2, you're going to have 2 solutions, but they might be the same, as is the case here. X equals negative 3 and x equals negative 3 here. You're told that the only possible value for x is negative 3. Well, it is a quadratic equation. That means you have 2 solutions that are negative 3. So we're going to take that and work backwards to the quadratic equation, and then we'll be able to see what m is, that middle coefficient. So if x equals negative 3 and x equals negative 3, you can add 3 to both sides of both equations. Get x plus 3 equals 0 and x plus 3 equals 0. Now if you take that x plus 3 and that x plus 3, they're both equal to 0. If you multiply them together, that'll be equal to 0. So multiply x plus 3 by x plus 3, set that equal to 0. Now everybody knows FOIL method distributive property. FOIL method distributive property there, x plus 3 times x plus 3, it's going to be x squared plus 6x plus 9. Remember, we need to find the value of m. So we need to find that middle coefficient. Well, it's right there. The value of m is 6. And that happens to be letter C. The solution set of which of the following equations is a set of real numbers that are 5 units from negative 3? Well, 5 units from negative 3, if you go to the left of negative 3, 5 units, it's going to be negative 8. If you go to the right, 5 units from negative 3, it's going to be positive 2. So we're looking for an equation that has a solution set of negative 8 and positive 2. Let's just take the first one. Absolute value of x plus 3 equals 5. Absolute value means the distance away from 0. So if that says the absolute value of x plus 3 equals 5, that means the distance x plus 3 is away from 0 is 5. There are 2 numbers that are 5 away from 0. There are 5 and negative 5. So if the distance x plus 3 is from 0 is 5, x plus 3 could be 5, or x plus 3 could be negative 5. Solve each one of those for x and see what happens. Subtract 3 from each side to get x equals 2. Subtract 3 from each side here and you get x equals negative 8. So right there, we got what we're looking for. We want negative 8 and 2 as the solution set. And that's what we have, 2, negative 8. Remember this, the solution set of which of the following equations is the set of real numbers that are 5 units from -3? The two numbers we're looking for are -8 and 2. That's what we have here when we solve this first one for x. So that means the first one, letter F, is the correct answer.